In this video, we'll be talking about how to handle complex fractions. Now, by a complex fraction, what we really mean is a fractional expression with separate fractions in either the numerator or in the denominator, or possibly in both. So the basic idea here is that we're basically having fractions within fractions, or if you can follow the expression, fractionception, so to speak. As an example of this, let's consider how to simplify the following complex fraction. Now, this fraction is complex because it has a fraction in the numerator and a fraction in the denominator. To simplify this, let's go ahead and simplify the top and simplify the bottom, putting them into single fractions, and then we'll go ahead and just perform the division. So here, to go ahead and put these as two common fractions, we need a common denominator in the numerator. So we have 2 over x minus 3x over x. That's in the numerator. In the denominator, we have x minus 1 over x minus 1 minus 1 over x minus 1. So what do we actually have here? Well, if we put these together, we actually have 2 minus 3x over x. And what we're doing is we're dividing by all of the bottom, which is x minus 1 minus 1 over x minus 1. Well, if we go ahead and flip and simplify, we have 2 minus 3x over x times x minus 1 over x minus 2. And then we can go ahead and just multiply, do the multiplication through. So what we end up with is 2 minus 3x times x minus 1 over x times x minus 2. Or if you prefer for things to be expanded out, you would have foiling 2x minus 2x minus 3x. First, I did the inner first, then the outer, so minus 2, and then last, so plus 3x. Inner is 3x squared over x squared minus 2x, which, in other words, we have negative 3x squared minus plus 5x minus 2 over x squared minus 2x. So whichever you prefer. I think the book usually prefers this. And now it's time for you to try an example. So go ahead and simplify the following complex fraction. So I'll make the solution appear on the count of 3. 1, 2, 3. So we see here that, again, I wrote the answer as either in factored form or in the expanded out form. Another way to handle complex fractions, though, is to use the LCD to cancel. Namely, if we multiply, we can multiply top and bottom of the expression by a common denominator for each of them. So if we take a common denominator of this and that all together, it's x and x minus 1. And then the bottom is x and x minus 1 as well. Put them all together. So multiply top and bottom by that, common denominator. And you end up with 2. So you would have 2 over x times x minus 1 minus 3 times x minus 1. All over x times x minus 1, because of the 1 there, minus 1 over x minus 1 times x minus 1. And what this will allow you to do is then cancel any denominators in both the numerator and in the denominator. So the x and the x will cancel there, and here the x minus 1, the x minus 1 will cancel. This leaves us with 2 times x minus 1, which is 2x minus 2, minus 3x squared plus 3x all over x squared minus x minus another x, which is the same thing as negative 2x squared plus 5x minus 2 all over x squared minus 2x, which is what we got before. So now, if you'd like to try this out, go ahead and repeat the last problem you did using this approach. You should be able to get the same answer. And the nice thing about this approach is that you don't have to do any of this division of fractions. You basically just cancel out each of your denominators by multiplying by the LCD. For more practice in working with complex fractions, be sure to look at the textbook pages A42 and A43, numbers 3 and 49 through 54. In our next video, we'll finally start solving equations by first considering linear equations.